and also acknowledge the traditional custodians of the land from which I am speaking from, and pay my respects to elders past, present, and future. So on the screen here are some images made by amateur meteorologist Luke Howard. And the cloud classification scheme that Howard outlined in his 1803 essay on the modification of clouds, which is still the foundation of the classification systems that we use for clouds today, aimed to create a system through which distinct modifications of clouds could be identified. So as modifications, the classifications didn't particularly denote precise forms, but matters of aggregation, how elements, water, particles that make up clouds cluster or accumulate together. Howard's scheme and its later use in the International Cloud Atlas are noted by Lorraine Daston as an attempt to create a systematized vision, which, in order to work, relied on cloud observers seeing in the same way. And this involved the occlusion of all the most salient details and the ignoring of other details that might interrupt that particular classification. And images alongside textual descriptions played an important part in establishing this alignment of seeing. And a lot of thought went into creating and selecting images that typified features of distinct modifications. Attempts to classify clouds such as Howard's, according to Shannon Matten, was the peak and rise of modes of analysis, description, and classification that occurred in the 17th and 18th centuries in response to a growing proliferation of data in an increasingly globalized world. And there are a lot of similarities for me that can be drawn between this and our contemporary moment with machine learning, as it too relies heavily on images and their proliferation as data. And it operates through the identification of common salient features that are kind of lead towards predictive statements. Today, I want to talk a bit about my creative practice, which is part of my PhD research, where I am studying with Anna. And I specifically want to look at a work in progress called Infinite Descriptor. And a part of that work is playing in the slide at the moment. And I'd like to share some observations on and experiences with working with machine learning and its modifications that I've come across through my practice. And at the center of this work are clouds. Clouds as protean meteorological phenomena, images of clouds, systems that attempt to classify clouds, clouds as metaphor, the cloud, and cloudiness. And broadly described, the work is an installation, which unfortunately I can't show you today, where three different image recognition platforms take a walk through a latent space of a cloudy predictive model. So as I mentioned, playing in the slide is a video of the work or from the work that forms, I guess, a key part of it. And this video was made by training a generative adversarial network, or GAN, with cloud images in order to create a model that can create images of a similar kind. And the video was made by generating images from a latent walk and then interpolating between those images in the vector space of the GAN model. Stills from this video were shown to three different image classification platforms, such as Google's Cloud Vision. And for the same still, each platform gave different classifications, which I then used to generate a spoken conversation between three different entities that for me embodied different modes of description about what is seen in the video. And this is a little bit of a diagram of that process. But I did find in the making of this work that the process doesn't really unfold in the, I guess, the linearity or automaticity that this diagram conveys. So as a walk, the work references an empiricism of romantic nature writing, where walking was viewed as a means for directly encountering, observing, and describing the landscape. For Timothy Morton, nature writing of this kind seeks to create a kind of immediacy to produce an impression of unmediated contact with the environment, as if there is no aesthetic framework. So it kind of has a quality of unworking or automaticity or foundness. Nature writing, however, always fails for Morton because the very processes that it uses to produce this sense of immediacy, such as statements like, as I write, I am immersed in nature, in turn destabilize it because they reference, in this case, the writing itself. And there are two interesting links to machine learning here for me. First of all, as a practice, it similarly evokes the idea of being an immediate description, that a function or predictive relation can be generated by statistical modeling of data, and that it is an observation and discovery of an existing interrelation in the world, a ground truth. In my practice, I'm really curious as to whether there are aspects of machine learning processes that interfere with this immediacy. And by placing the three platforms or image recognition platforms into some type of conversation for me is a method of disrupting this immediacy as we get a sense of their differences, that as forms of description, they are not homogeneous nor automatic. And second is the idea of the latent walk as a means of traversing and observing the vector space of a machine learning model. These are also empirical attempts to observe and represent machine learning itself. However, like clouds, they also elude our attempts to describe them. And in large part, this is because the operativity of machine learning is not something that we can directly see. The images of the latent walk are not a direct observation of the GAN itself, but they are generated by the GAN as a computational process. Before I began working with clouds, I was experimenting with adversarial images. And this is a screenshot of an early experiment where I was working in the game engine Unity. And basically I had this adversarial images floating in three-dimensional space and three different camera objects that were taking photos of this image, passing those images to image recognition platforms online using web requests, and then bringing the classifications back into and putting them over the images that they sent out. And adversarial images are images that are evolved or generated to have features that can provoke a specific classification from an image classification model with a high degree of confidence. Even if that image might in some cases not look like anything recognizable or recognizable as such to us. A 2019 study suggested that adversarial images can be contributed to non-robust features that are learnt by the model. These are features generated from patterns across the training distribution that are highly predictable yet incomprehensible to humans. In other words, as the paper's title suggests, adversarial images are not bugs, but they are features. They occur because an image classifier's main purpose is to model a training dataset's distribution, whether those predictable features are human interpretable or not. This type of adversarial activation also happens unintentionally through features in input data just happening to affect the specific weights in an image recognition model. It was considering how these activations occur in the wild that I began working with clouds. And that's because of the slippages that clouds can provoke in systems of representation and classification. This is another progress image where I started to work with generating clouds in Unity. And eventually I moved on to working with GANs to produce images instead. And I'm going to talk about my use of GANs a little bit later on. But I moved towards GANs because I was interested in how images generated by GANs are entering into the image ecology. So that can be images that we see, but they're also seen by images as parts of training data sets and images that are potentially classified. But to return to clouds, an enduring resistance to representation by clouds has cut across many strategies of classification and imaging. Early attempts to photograph clouds using daguerreotypes often failed to capture them as they did not stay in one form long enough for the long exposure times. Many earlier daguerreotypes, such as this one, are cloudless with mottled, dull skies. Luke Howard's classification scheme that I spoke about at the beginning of this talk also includes hyphenation, such as cirrocumulus, in order to encompass their mutability. And clouds are difficult and challenging to simulate computationally, for example, in visual effects and climate modeling. For Lorraine Daston, clouds are kind of like an ultimate phenomena for examining the limits of representation, having challenged description in both art and science by way of their variety. Clouds can take on a multitude of forms and variability, their ever-changing flux. In putting clouds into, or generated clouds into different image recognition platforms, I came to view them as a different sort of adversarial image, not in the sense that they are generated in oppositional relation to an image classification model to produce when classified a specific type of classification, but more in the sense of being in conflict by way of their variety, their many different aggregations, and variance as an infinitely changing continuum, potentially prompting many different classifications. The video I showed at the beginning of this talk was made by, as I said, taking a latent walk through a GAN model trained using photographic images of clouds. The training data set was created through a set of cloud images downloaded from the GLOBE program, which stands for Global Learning and Observations to Benefit the Environment. This is a citizen science project which was started on Earth Day 1995, and it's about collecting data from local environments for use in science and education. And there are over 203 million measurements in this data set, but it's only been since about 2014 that photographic data has been included. And this was an intriguing data set for me because it involved over a long period of time these observations and a kind of collective seeing which referenced back to my topic matter. Working with GANs was interesting to me because unlike forms of supervised learning, GANs generate a model by mapping a data distribution into a vector space, like forms of supervised learning, but the generation of the model can be described as situational, as it is not being resolved towards being able to predict already defined categories or measures. Training the cloud GAN and seeing after numerous epochs the test images, I had a feeling of the vector space of the GAN being malleable, or like the modification of clouds, of it being a shifting aggregation. Adrian McKenzie has described data work with machine learning as less like stepping through data over time and more about transformation in the sense of folding a pliable material, as vector space can be constantly reshaped. I used transfer learning to train the GAN on top of a wiki art model. So in the beginning of these images, you can see images that kind of look like artistic images, and then gradually they become more cloud-like as I'm training on top of an already trained model. And the shape-shifting quality, I guess, of these images and of the cloudy latent walk, for me, I hope sparks some kind of analogical speculation. What does this image or cloud resemble? And for me, another type of analogical reading can be glimpsed in the just visible movement of these clouds, or even of the kind of set of images that were generated by the GAN that I put up here, and that is of the model itself. And in a discussion of viewing the latent space of GANs, Fabian Offert, who's going to be speaking tomorrow, brought to mind for me a kind of similarity to the idea of the nature writing I discussed at the beginning of this talk. And that's the idea of a description pointing to the very processes of its emergence. Offert outlines how GAN space can produce actual images. So these images look like clouds, but they are also analogical images. When we see them as a set, like here, or in a latent walk, they can operate as an analogy for the model's perspective of the world. So moving through GAN space offers some sense of its material reality and transformations or modifications, the aggregation of images and how they come to matter within vector space. And that's the end of my talk.